Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Welcome to Astronomy Daily. Today is the 15th of May 2023. Today we'll be constantly talking about the Hubble constant, and we'll be talking about Skylab. I'm Steve Dunkley, your host. Welcome aboard.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And welcome to my very favourite digital assistant. How are you, Hallie?
Hi, they're human.
Yes, I'm back again.
It's great to hear you sounding more like yourself today.
Yes, I got over my second stint of COVID.
Great news.
Yes, I wanted a holiday, but that's not what I meant.
Are you ready to go?
I sure am, Hallie. Let's go.
Okay, here's some short takes. A crucial radar antenna on a European spacecraft bound for Jupiter is no longer jammed. Flight controllers in Germany freed the 16-meter, 52-foot antenna on Friday after nearly a month of effort. The European Space Agency's Jupiter Icy Moons Explorer, nicknamed JUICE, blasted off in April on a decade-long voyage, but soon after launch, a tiny pin refused to budge and prevented the antenna from fully opening. Controllers tried shaking and warming the spacecraft to get the pin to move by just millimeters, and back-to-back jolts finally did the trick. The radar antenna will peer deep beneath the icy crust of 3 Jupiter moons suspected of harboring underground oceans, and possibly life. Those moons are Callisto, Europa and Ganymede, the largest moon in the solar system. JUICE will attempt to go into orbit around Ganymede. No spacecraft has ever orbited a moon other than our own. The news wasn't so good for NASA's Lunar Flashlight spacecraft. After struggling unsuccessfully for months to get the CubeSat into orbit around the moon, the space agency called it quits on Friday. Launched in December, the Lunar Flashlight was supposed to hunt for ice in the shadowed craters of the lunar South Pole. Now it's headed back toward Earth and then into deep space, continually orbiting the Sun. That's a sad end for CubeSat, isn't it, Steve?
Well, I sure hope they can find something else for it to do out there.
2 Russian cosmonauts have completed a spacewalk to activate a radiator that they earlier helped relocate outside of the International Space Station. Expedition 69 Commander Sergei Prokopyev and flight engineer Dmitry Petlin, both with the Russian Federal Space Corporation Roscosmos, successfully deployed the heat exchanger during the 5-hour and 14-minute EVA outside the International Space Station on Friday, May 12. The spacewalk was the third and last in a series that focused on outfitting the exterior of the Russian Nauka multipurpose laboratory module with the radiator, and an experiment airlock that was launched with the Rassvet mini research module aboard NASA's Space Shuttle Atlantis 13 years ago. After opening the airlock hatch on the Poisk module and exiting the station, Prokopyev and Petlin made their way to the Nauka module to remove the remaining restraints holding the radiator closed. As the bolts were loosened, the radiator began to unfold to its full length. While waiting for the radiator to fill with coolant, they went about several other maintenance activities, which included work on the station's manipulator arm and installing new handrails. With Friday's EVA, Prokopyev now has spent 42 hours and 16 minutes on 6 spacewalks. Petlin has now completed 4 outings, logging 26 hours and 45 minutes outside the station. The spacewalk was the 6th for the year and 263rd dedicated to assembly and maintenance of the International Space Station. Do you remember Val Kilmer in your favorite movie Red Planet, Steve?
Oh yes, I remember that one, Hallie.
He was the space janitor on that ship doing all the odd jobs.
Oh, I'm sure real life is a little bit more sophisticated than Hollywood.
Sure it is, Steve. You keep telling yourself that. And finally, for the first time, astronomers have captured images that show a star consuming one of its planets. The star, named ZTF SLRN 2020, is located in the Milky Way galaxy, in the constellation Aquila. As the star swallowed its planet, the star brightened to 100 times its normal level, allowing the 26-person team of astronomers to detect this event as it happened. Morgan McLeod is a theoretical astrophysicist who developed computer models that the team used to interpret the collected data from telescopes. Although only the effects on the star were seen, not the planet itself, the team is confident that the event we witnessed was a star swallowing its planet. Witnessing such an event for the first time has confirmed the long-standing assumption that stars swallow their planets and has illuminated how this fascinating process plays out. In 2020, the star ZTF SLRN 2020 suddenly became 100 times brighter in visible light over just 10 days. It then slowly started to fade back toward its normal brightness. About 9 months before, the same object started to emit a lot of infrared light, too. This is exactly what it looks like when two stars merge together. With one critical difference, everything was scaled down. The brightness and total energy of this event were about 1,000 times lower than any of the merging stellar pairs astronomers had found to date. In the case of ZTF SLRN 2020, the orbit of the planet shrank slowly at first, then faster and faster as the planet smashed through the denser layers of the star's atmosphere. Eventually, in just a few final days, the planet plunged below the surface of the star and was torn apart by the heat and force of the collision. This rapid injection of energy supplied heat to power ZTF SLRN 2020's 10-day, 100-fold increase in brightness. Following this climactic moment, the star began to fade, telling our team that the planet swallowing process was over and that the star was beginning to go back to business as usual. And now, back to you, Steve.
Astronomy Daily, the podcast.
Thank you, Hallie. Thanks for keeping us up to date with all the bits and pieces. Here's an interesting story. More discussions about the Hubble constant, and research continues, and it's about our journey through the universe and how to measure that. Indeed, how did we get here? Where are we going? And how long will it take? It sounds like the kids in the back seat of the car, doesn't it? Are we there yet? These questions are as old as humanity itself, and if they've already been asked by other species elsewhere in the universe, potentially they are much older than we are. Well, they are some of the fundamental questions we're trying to answer in the study of the universe called cosmology. One cosmological conundrum is how fast the universe is actually expanding, which is measured by that Hubble constant. And here is quite a lot of tension around that constant. In two new papers led by Patrick Kelly at the University of Minnesota, there's a successful new technique involving light from an exploding star that arrived on Earth via multiple winding routes through the expanding universe to measure the Hubble constant. The papers are published, of course, in Science and the Astrophysical Journal. And if our results don't resolve the tension, they do give us another clue and more questions to ask. And isn't that always the way? We have known since 1920s that the universe is expanding, and around 1908 an astronomer, Henrietta Leavitt, found a way to measure the intrinsic brightness of a kind of star called a Cepheid, a variable, not how bright they appear from Earth, which depends on distance and other factors, but how bright they really are. The actual brightness. Cepheids grow brighter and dimmer in regular cycles, and Leavitt showed the intrinsic brightness was related to the length of this cycle. Leavitt's law, as it's now called, lets scientists use Cepheids as a standard candles object whose intrinsic brightness is known and therefore whose distance can be calculated. Now, how does this work? Imagine it's night and you're standing on a long dark street or a highway with only a few light poles going down the road. And now imagine every light pole has the same type of bulb with the same power, so you know the exact brightness of each pole. You'll notice the distance ones appear more faint than the nearby ones. We know that the light fades proportionally to its distance and in something called the inverse square law for light. Now, if you can measure how bright each star appears to you, and if you already know how bright it should be, then you can figure out how far away each light actually is. In 1929, another US astronomer, Edward Hubble himself, was able to find a number of these Cepheid stars in other galaxies and measure the distance. And from those distances and other measurements, he could determine that the universe was expanding. This standard candle method is a powerful one, allowing us to measure the vast universe. We are always looking for different candles that can be better measured and seen at much greater distances. Some recent efforts to measure the universe further from Earth, like the SHOES project, led by Nobel laureate Adam Rees, have used Cepheids alongside a type of exploding star called a type La supernova, which can also be used as a standard candle. There are also other methods to measure Hubble's constant, such as one that uses the cosmic microwave background, relic light or radiation that began to travel through the universe shortly after the Big Bang. The problem is that these two measurements, one nearby using supernova and Cepheids and one much further away using microwave background, differ by nearly 10%. Astronomers call this difference the Hubble tension and have been looking for new measurements and techniques to resolve it. So the big question remains, are we there yet? Well, I dare you to tell the kids in the back seat of the car, we don't know yet. Now here's a story that I'm kind of excited about. I wonder if there's any other 59-year-old people out there listening to this remembering something that happened 50 years ago. Do you remember Skylab? Yeah, that's right. 50 years ago, Skylab was launched into orbit. And there is another fellow, astronaut Stephen Bowen, remembers that for a very special reason, and it's exactly the same reason that I remember it as well. At 8 years of age, just like me, Bowen's experience watching the United States' first space station cross the night sky fueled his interest in spaceflight. Little did he know then that it would also play a huge part in his future. He says, "I do remember that it was Skylab. My dad took us outside and we watched it fly over our house one night. I think it was the first object I saw in space, as in man-made object seen from Earth," he said. Now, I can remember that myself. My father and I used to go out satellite spotting, and I don't know how he did it. He just had eagle eyes, but he would say, "There's one, and there's another one," and I learned how to see the movement in the sky, and now I see them all the time. And it's just, I think my friends wonder how I managed to pick them out of the starry expanse so easily, because I guess it's something you become sensitive to, but there it is. Skylab, I remember watching that with my dad out in the backyard. Today, May 14, it says, which was yesterday for us here in Australia, on the 50th anniversary of Skylab's launch, it's Bowen who is in Earth's orbit. At 59, he's the only crew member currently on the ISS who is old enough to remember the orbital workshop's start and subsequent crewed expeditions. He says, "I do have a very specific memory of those missions. Unlike the International Space Station, which took 10 years and more than 30 missions to assemble, Skylab was lifted into orbit by a single Saturn V, the last of the Apollo moon boosters to fly. The space station was built from and took the place of the rocket's third stage." In addition to the orbital workshop, the S01VB stage was fitted out with a solar observatory called the Apollo Telescope Mount, a multiple docking adapter, an airlock module, and solar arrays. Skylab mission lifted off at 1:30 p.m. Eastern Time from the pad 39A at NASA's Kennedy Space Center in Florida. For the first minute of the flight, everything went to plan, but then the station's micrometeorite shield and sunshade, as well as one of its solar arrays, fell victim to supersonic environment and were torn off. Those components, which were crucial to the Skylab's operation, were lost, and debris from the shield became entangled with the remaining solar array, preventing its full deployment. And I remember seeing it all on the news. Skylab made it into orbit, but with significant power deficiency and without the ability to control the temperature inside the workshop from exceeding livable conditions. The launch of its first three-person crew, which had been scheduled for the next day, was delayed till May 25, as engineers worked to quickly devise how the astronauts would save the situation. Ultimately, the Skylab 2 and 3 crews were able to free the stuck array and install replacement sunshades. Such they and a third mission lived in the workshop for different increasing durations from just under a month to 84 days long. The research and experience gained on those 3 flights set the foundation for the US-led operations on the International Space Station and a continuous presence of humans in space for now 23 years. Astronaut Bowen says it's really exciting to sort of carry on that legacy of living on a space station. And I'm so glad that my dad took the time to point out this amazing thing hurtling across the sky in East Maitland, where I grew up as well. It sure is the sort of thing that makes a young kid grow an active imagination about what's possible in the future. And what do you know? That's about all we have time for today in Astronomy Daily. Thank you so much for joining us. I hope you got something out of today's episode. And we'll be looking forward to seeing you again very, very soon. Why don't you take us out, Ali?
Okay, no problem. Don't forget you can find all the back episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson at our homepage.
And that address is spacenuts.io, Hallie.
And all of our Astronomy Daily episodes can be found there as well.
And don't forget you can drop in at our Facebook page, Space Nuts, on Facebook. And we'd love to hear from you.
Yes, we love to hear from you to hear about what's happening in your sky.
And that's what we always say, don't we?
Keep your eyes on the skies.
See you next time.
Astronomy Daily, the podcast, with your host, Steve Dunkley.